Okay, so to start off, we had a question from Mike that dealt with the date variable. So there are some predefined variables in Mastercam, and I guess it was the day variable, excuse me. But starting with date, we have date $, we have time $, day $, month, year, and MON $. So month, MONTH versus MON. Each of these will let you get a portion of the system day or time. The date variable itself will automatically output the day, month, and year in 2-digit format, but only when there is no format assigned to the date variable. So if you look in the FMT section, which is format assignment, if you add any formatting to date, you can put whatever you want for a prefix string. But as soon as you add a format, and it can be any format, as soon as you add that format to the date variable, MPDLL changes the way this works, changes the way it gets output. So if we look at the MP documentation, as soon as you put any type of formatting to it, the date variable changes to a number between 0 and 6, which then indicates the day of the week, Sunday through Saturday. Sunday being 0, Saturday being 6. And the reason it does this is so that you could then use the date variable in a string select function to actually allow you to select the actual day of the week. None of these other variables, time, date, day, all of these are numeric, indicating the day of the month. So the question is, okay, we don't have a formatting assigned to this. Well, how do we output the date values? If you look in P header, the default here is to have this line of code output your day and time. And it gives you date with this string in front, so day, month, year, and then it outputs the actual date. And then it outputs the string time, HH:MM, and then it outputs the time as the time variable. So Mike is then trying to use this guy here, or one of these other ones, where we have month, and we have day, and we have year. Actually, it was this next guy. So he's taken off the pound sign in front of here and added the pound sign here. And now he's getting month, and we need to add the asterisks in front of day and in front of year in order to force those out. Now he does that, and he's getting the month, the day, and the year, but they have a decimal point after each of those integers that is coming out. The reason for that has to do with the PSM file. The actual binned portion of the file has a section of code that is used to check the time limit. So by default, this is turned off. You'll never encounter it with the regular PSB. It's only for people who have the full copy of the post and want to add the timeout code. So the secret for you, Mike, in order to get this to work is to use the new FS function. So new FS stands for new format statement, and it allows us to apply a new format statement to a variable. If we go back and look, let me set a bookmark here. So I'm going to right click, bookmarks, toggle bookmark. And if we go back up to the FMT section, this section here, so these are format assignments, and format assignments tell MP, here's a variable, this is the name of the variable, and I want to format it. I want to put a string, a prefix string, in front of the numeric value, and the third section here, so we've got FMT, which tells MP this is a format assignment line. Then we have the prefix string, in this case the letter D. Then we pick the number of the format statement that we want to apply to the variable. The format statements are listed up above. And you'll notice that some of them get used quite a lot. Format statement number 4 is a pretty popular one because this is just regular integer output. And if we look down, things like gear range, spindle speed, WCS G address, tool length number, all of these are assigned format statement number 4. The issue we're running into is that by default, day, month, and year are assigned format statement number 1. So what we're going to do, we're going to go back to P header. So let's set a bookmark up here, just in case we need to get back. And I'll do Control-Shift+ to jump to the next one. So what we need to do is just prior to outputting these variables, we need to assign a new format statement. So I'm going to go just below the custom changes allowed below, and I'll make sure to insert at least one space, but the default indentation is 6 spaces. So just as a heads up, try, whenever you're inside a post block, always try to start with at least 6 spaces. Almost every post has a numeric variable initialized called result. And this is the return variable for a function call. You don't have to use result. You could create your own result-like variable to hold the result of the function. But this is how we call a post function. So result equals NEW. Let's see if I can I'm going to move my cursor out of the way so it doesn't automatically pop up. I'll start typing. And of course, unfortunately, it hides that list as I do it, but there we go. So as long as I keep my cursor over the little scroll bar there, it doesn't automatically pop up the help file. So this is a list of all of the post block strings, functions, operators, and what's this last one here? Variables. So post blocks, strings, variables, operators, and functions. And these are filters down at the bottom. So if I turn off post blocks that start with N, if I turn off strings, variables, So now I'm left with operators and functions. Ooh. Yeah, so I guess they're calling this yeah, I guess they're calling this an operator. There we go. Okay. So it is new FS. There, it's better. Sorry, it keeps popping up this little thing right over the top of it. And new FS allows us to assign a new format statement to a variable. If we look at the little pop-up help bubble that comes up, you'll notice what it says in the description. Assign new format statement. Return, and in this case, the name of our variable is result, but it performs the same function. Return equals new fs n comma x. So this is the format that we have to pass variables to the function in. There are two arguments, which is what the variables that we pass to a function are called, and they're separated by a comma and enclosed in parentheses. Assigns the format statement n to variable x, replacing the existing assignment. Returns 1 if successful. So in this case, we're going to type in new fs, open parenthesis, and we're going to assign format statement number 4, which is integer, to month. Okay, so this month variable down here, which was assigned format statement number 1, now gets new fs 4. I'm going to copy that because I want to use new fs again, and I want to use it with format statement number 4. I just want to apply it to a couple of different variables. So we're going to apply that today, and we're going to apply it to year. So by using that new fs statement before the variables are output, we can on the fly give them a new format. And if you try that in your postmine, you should now see that you get the date as the integer digits without the decimal points. So that worked? I take it? Looks like it did. Okay. That's a great question. So Mark asks, should you set them back at the end of the p header post block? In general, yes. If you are setting them to a new format statement, then what you want to be careful of is, are these variables used elsewhere in the post? And is assigning them a new format statement going to break anything? In this case, you are fine not doing anything. The only other place these variables are used is inside a post block that is not enabled by default. if you are using the generic Fanuc 5xmil post with the generic Fanuc 5xmil PSB file, this post block is not enabled. So it's in there, but if we search for the call to it, you'll see that there is a pound sign in front of p timeout, not used with generic. So the default is to have that post block not enabled and for it never to be called. The only way to enable it is if you have access to the PSM, which doesn't really happen. I mean, you have to know some people to get that. I happen to know some people. I worked at CNC Software, and I use it, like this as part of a demo. But quite honestly, when I'm building a new post for somebody, I always start with generic Fanuc 5xmil PST and PSB. I don't ever use the PSM because it doesn't get me anything. I know how to manipulate the PST portion of the post well enough that I treat the PSB like the black box it is and don't worry about try to, edit stuff in the PSB. I just edit it in the proper spot in the PSM to make it work. But yes, in general, if we were using this new FS, it is a best practice to assign the new format statement before you use the variables. And then at the end of the block where you've used them, we would then reapply the original format statement. That would be the best practice way to do it. In this case, because these aren't going to be used anywhere else, I mean, the only real place we're going to use day, month, and time and year is in the header, right? I mean, you're going to output the time that the program was posted, but I've never seen anybody need to output the date and time info at the end of the program. So in this case, we can not do that and not cause any harm. Okay? But yeah, that was a great question. And I think in general, if you assign something a new FS, you want to set it back to the original. And we do this with dwell all the time. Okay, so if we look at so here's a good example of that, where in pdrill common B, we said, all right, if dwell is greater than 99, we're going to make it a variable. So we're going to assign it a new format statement of 4. We're going to give it a prefix of P open square bracket pound, and we're going to give it a suffix of close square bracket. And if it's any other condition, so if it's not greater than 99, then we reassign it back to the original formatting. And you'll see, a good post writer do stuff like this a lot, where if they're going to assign a new format, then they make sure they reassign it the original format after they're done using it. That way they don't mess anything up. Okay. At this point in our class, I like to start diving into what makes the logic tick for all of the math functions in the post. What do we really need in order to calculate 5-axis output? There is, in the documentation we go to the MP documentation, where did this go? You can find this section in this legacy docs. If I go to legacy docs, in here is the old stuff from back from version 9. I'm actually going to get to that through an older copy of the documentation, because I think they might have made some little minor changes. And just in case, we're gonna go reference the older one. MP documentation. Okay. So in the older set of documentation, they had MP reference guides, volume 1, volume 2, and volume 3. Volume 1 was like the introduction to the MP post language. Volume 3 is the language reference. This is where we list every variable, every post block, every function, and give a description of that. And Volume 2 was known as Advanced MP Language, I think Functions and Applications. What was it? Concepts and applications. So inside volume 2, we have how subprograms work. So there's a whole chapter that's devoted to explaining the mechanism in both MP and the NCI file that allows subprogramming. There's a section, a chapter on buffers. Talks about how to create and use buffer files. There's an option here for parameter information. Starting around X5, the old parameter stuff was replaced with the new parameter lookup functions and information. So there's a new guide that talks about that. The intersection function is used to calculate intersections inside the post processor. So this was useful for different types of math routines where you need to calculate intersection points. And rotary processing is kind of the big one. So rotary processing tells us how MPDLL works in the background to calculate rotary values. Typically that's for a 4-axis post, although there are some 5-axis calculation settings. It also talks about the different types of rotary processing. So what are the different cut types? Tool plane, polar, axis substitution, and then vector-based toolpaths. So there's 4 different types. We also talk about the variables that are involved on the posting level. So there are some different variables that affect both 4 and 5-axis processing and math routines inside the post. And then at the end of this section, there is a short sample that talks about how to calculate 5-axis positions using the math. So we're going to go through this and review the post settings, and then we're going to go and write some code to calculate sample 5-axis output. So, Chapter 6, Rotary Processing. Processing of the rotary NCI data passed to the post executable is very dependent on the settings in the post file and the post writer's preference. This chapter maps the various routines that may be called based on post switch variable settings. This information is important if you are examining a post customization file and want to determine what processors are being called in the post executable. This chapter also contains examples of MP language code to process the various rotary options in the context of basic 4-axis and 5-axis post customization files. Note, the information in this chapter does not apply to wire. Mastercam provides information to the post executable and customization file to determine a rotary axis toolpath type. However, this NCI file data is not in a condition to be formatted and output to the NC file. It only indicates that the Mastercam user desires the NC output to reflect the selections he has made. To make that happen requires a lot of work on the post customization file. As you will see, the post executable provides the tools to calculate rotary output, but does little of the actual work required. Rotary processing types. Mastercam provides 4 types of toolpath information that can be used to derive rotary output. Tool plane. Any toolpath that is not a 4 or 5-axis vector toolpath can use the tool plane for the toolpath to determine a rotary position. The tool plane must be compared to a base matrix that defines a machine reference. Polar. A 3-axis toolpath can be converted to polar coordinates, radius and angle about a center of rotation. This work is handled in the post customization file. For milling, we very rarely ever use polar coordinates. But the place this comes up a lot is with lathe work. When you have a machine that has basically X and Z and C, and you want to take an XY path on the face and convert it into polar output. Axis substitution. A 3-axis toolpath can have a single linear axis substituted to a rotary output as a function of the axis position. Even though a mechanism is provided in the post executable to perform this work, often it is not used because the routine to break lines does not calculate the numeric variables XS and YS. This work is then handled in the post customization file. Now keep in mind, when you read some of these comments here, they are from back in the version 9 days, and some of these limitations that they mention have been overcome. So just take some of the things that they tell you sometimes with a grain of salt, because often it's been improved upon. 4 and 5-axis vectors. This type is commonly known as a 5-axis toolpath. The tool motion is always a vector, represented by the absolute XYZ endpoint as the tool tip or tool center, and the absolute UVW point, that is the tool centerline direction, added to the XYZ endpoint. From this vector, the rotary angle can be calculated. So this is really important to understand. It's really essential to understanding a 5-axis post in general. There are no rotary angles output from the Mastercam toolpath. All of the rotation is derived from vector or matrix math functions inside the post or inside MPDLL itself. Whenever they talk about the post customization file, it's really referring to, I guess in this case, both. The post customization file is typically just the PST, but in the case of the 5-axis, it is the combination of them. Now, being that they're talking in terms of general math functionality here, we could also call this either the PST or the PSM. So whenever we are going to encrypt a portion of the post, we typically call the unencrypted post the PSM, which stands for the master, and that creates the PST and the PSB file. So when you basically, you can go and also use, so if you look inside the documentation, there is a guide in here, MP-BinX User's Guide. And I would encourage everybody to read this. Basically, it talks about the process of encrypting a post processor. So how do you take a portion of the post and encrypt it? With the generic Fanuc 5x mil post, even this post that we're working with now, we can add a second or third section of encrypted data to our PSB file. So, for example, if we take this post processor, our OKK VCX 5X post, and we get this thing super dialed in, and we really like it, and it runs this machine really well, and then somebody wants to buy a copy of it, there's no reason we cannot encrypt another portion of this post and run it again through the MP-bin utility. So basically, let's say, for example, we wanted to encrypt pdrill common B, because we've done a bunch of work in here. We could go and say, all right, I'm going to add my start bin. So it's all capital letters. Start bin in surrounded by square brackets, and end bin surrounded by square brackets. And if I did that and I ran this through MPDLL, this section of code would be encrypted and it would be added to the existing PSB. If you want to learn more about how to do that, I would encourage you to read in the guide about it. We could spend all day messing around with that. Okay. In Mastercam, you must select the Toolpath type to generate the rotary output. As already explained, the NCI file does not provide any angular data, so there's no rotation inside your NCI file. But it sets the parameters for the post executable and the post customization file to interpret. Post executable, when you hear that in this documentation, we're talking about MPDLL. Post customization file, this is the PST or PSM. Okay, the part that we are editing in order to provide instructions to the post executable. In particular, the post customization file must be written to process the NCI data and convert it into the desired output. A tool plane is the view that is normal to the tool direction with 3-axis machining. So the z-axis of our tool plane would be aligned or parallel to the tool axis no matter where that plane is located relative to our WCS. So this view is relative to the world coordinate system, which in Mastercam coincides with the top view. A rotary positioning move can be deduced if the tool plane matrix is different from a view matrix that is the machine base. So in other words, if we're running a vertical style machine, top would be our base matrix, and when we rotate a tool plane, the z-axis of that tool plane is no longer aligned with the z-axis of our WCS. And using vector math, we can deduce that rotary angle. With transform toolpaths, we can handle features that repeat about a rotary axis. So 4 features that repeat about a rotary axis, such as tombstone work, it is best to use the transform toolpath option. Select rotate and tool plane to rotate the original operation tool plane matrix as shown in the following illustration. So here we're showing rotating a tool plane path inside the transform. At the operation level, we have the rotary axis option. It used to be a checkbox button. In slightly more modern versions, yeah, the beautiful Windows 95-esque looking dialogues, yes. Now in the tree style toolpath, it's in the tree. It's no longer, it's no longer these oh so snazzy checkbox buttons that were grayed out when there was no checkbox and super hard to read. Why it keeps doing that? I think I must have like a key that's trying to like stuck down on my keyboard. I do not want to create this toolpath. No, stop it. Okay, rotary axis control, same deal. You get no rotation, rotary axis positioning. Now the silly thing, rotary axis positioning used to be the default. Now we've got no rotation. Rotary axis positioning and no rotation do the exact same thing. When it's set to no rotation, if you actually rotate your toolpath, you still get rotation. So why they gave us this little extra option here, maybe it's so they could now include, you know, rotate about X, Y, or Z. I'm not sure. But no rotation will still give you rotation with most post-process, most 4-axis and 5-axis post-processors. So these are essentially the same. 3-axis is polar, and axis substitution we've already talked about. That's when we wrap, or in the case of unroll, when we unwrap. Okay, so it talks about using polar. So 3-axis toolpaths that are to be converted to polar must be set as shown here. For axis substitution, they're set up as following. Axis sub, we substitute either X or Y. We choose the clockwise or counterclockwise rotation. Give it the rotary diameter. The unroll button is used if your geometry is not flat. So if you're chaining a piece of geometry that's already wrapped around the cylinder, you can check the unroll box and then give it a tolerance. I prefer, honestly, to already have unwrapped my geometry. I think it gives you a better result if you already unwrap it and make it flat and then use the settings like this. Multi-axis toolpaths generate vector toolpath data when the output options are selected for 4 or 5 axis. Any toolpath that produces vector data, which is NCIG code 11, falls in this category. Curve 5-axis, drill 5-axis, swerve 5x, flow, rotary 4x. There are obviously quite a few more that they've added with the addition of those module works toolpaths. But beyond the toolpath type, the data they produce, which is the NCIG code 11, is the same. Variables that control rotary processing. Many variables related to producing rotary output must be examined or set in the post-customization file. Use the rotary type to indicate which variables are important with any single rotary type. In many of the posts, a single user-defined numeric variable is created to detect the rotary type. See mpfan.pst. 4-axis motion description refers to motion in any 3 linear axes and a single rotary motion or rotary axis motion. 5-axis motion refers to motion in any 3 linear axes and up to 2 rotary axes of motion. Tool plane variables. Rotary underscore type. So keep in mind whenever we look at these variables in the older guide here, we typically need to add a $sign. So rotary underscore type $sign, M1 $sign through M9 $sign, and rotax type. So ROTAX TYP $sign. Rotary type set to 0 or 3 defines tool plane positioning. The tool plane matrix M1 through M9 and the rotax type settings are critical with tool plane positioning. With 4-axis positioning, the post executable with the correct rotax type setting should produce the calculated variable C for the rotary axis. So what you're going to see inside the post processor I'm going to go grab the generic Haas 4x mil post. Most of the 4-axis posts have logic like this. If VMC, which means that it is a vertical machine, rotax type equals 1. Else, rotax type equals -2. Rotx type is a very important variable because it is the general type of math calculations that need to be performed on the matrices in order to derive the correct rotary angle. So when we look back at this, the post guide here, we'll skip ahead real quick and look at the definition for Rotx type. The post switch variable that most heavily influences the rotary axis output is the numeric variable Rotx type. The Rotx type switch provides the selections for either one rotary axis or, for 5-axis motion, 2 rotary axes. Most post customization files are also developed along these lines and use 2 different techniques to produce output. So the Rotx type variable, you'll notice it says M, R, and L next to it. That stands for mill, router, and lathe. So what they're telling you is that this post switch variable applies to all 3 of these different product types. Variable type, post switch variable. Category, it's a rotary post switch. Sets the rotary axis procedure to be used by the post executable file. When Rotx type is set to -3, this is single axis rotation, sets the reference tool plane matrix to the side view for C angle equals 0. Rotation is about the z-axis of the WCS. C, which is always the internal variable calculated for a 4-axis machine, is returned in the range 0 to 360 degrees, counterclockwise positive. So this would actually set the right side plane z-axis equal to 0. I've yet to see a machine that uses a setting of -3, but I'm assuming they're out there somewhere. -2, single axis rotation. -2 is the typical setting that we use for a horizontal machining center. Sets the reference tool plane matrix equal to the front view for C angle equals 0. Rotation is about the z-axis of the WCS. C is returned in the range 0 to 360 degrees, counterclockwise positive. -1, single axis rotation. Reference tool plane is the top view for 0. Rotation is about the X or Y axis of the WCS. C is returned 0 to 360, clockwise, positive about X, counterclockwise, positive about Y. 0, single axis rotation. Reference tool plane matrix to the first operation view in the NCI file for C angle equal to 0. This is a special case. This was created for when you've got some kind of funky machine where the spindle comes in from a weird direction. I've only had to use this one time so far in the last 20 years, and that was for a horizontal machine where the spindle actually came in from the back side. So instead of the spindle approaching from front and having that be B0, the back side was B0. It was a funky machine, and the guy who programmed it wanted to see the spindle When you're looking in Mastercam in isometric view, he wanted to see that spindle coming in from the back. And so what we did is we made a point operation that was the first operation in every program that he was going to create. And that point operation used the back tool plane. And so the reference tool plane was equal to the first operations tool plane. That's the way that works. One reference tool plane is the top view, C angle 0. Rotation is about X or Y. Basically, this is identical. This is identical to the -1 setting. A setting of 2 is for 5-axis rotation, intended for rotary motion in the tables. Tool plane toolpaths must be supported in the post customization file. By calls to the post block PMX0 on every motion post block call. The post writer is responsible for all rotary calculations and position mapping. We typically don't use a setting of 2 very often because the post writer is still responsible for doing all the rotary calculations and position mapping. Most of the time, if you're doing 5-axis rotation, you're going to set it like we have it set in the Generic Fanuc 5x mil post to like 99. And that way it basically shuts off all of the automatic calculations and allows you to write your own code that you're going to have to basically do anyway for 5-axis. For mill turn applications, you can use a setting of 3, and this resolves the A and C angles when rotated about the X. So for it's got some things here for cross machining, for face machining, back machining, etc., and how those angles are calculated. 4 would be for rotary axis motion in the head. So this is head to head. You still are responsible for writing all the rotary calculations. Greater than 6. So this is typically what we use in a modern 5-axis post. Allows rotary support in the post by calls to the post block PMX0 on every motion post block call from P-Rapid to PG32E. Calls for the output blocks are limited to those normally called with 2D and 3D contour motion. The post writer is responsible for all rotary calculations and position mapping. Note, rotax type should be set to a large value, for example 9999, to allow future expansion of this variable by CNC software. I don't know why they tell you that. I think it's a little silly. We'll get back to something here in just a second. But what you'll see here in a 4-axis post is that we typically manipulate the variable rotax type. In the 5-axis posts, we do set rotax type. and it actually set inside the PSM file itself. So let's look at that. So this is how it's set internally inside the PSM file. Rodax type 9999. Just wanted to show that to you. So it is set to that value because we do all of the 5-axis calculations on our own. Okay, let's get finished with this 4-axis, and then we'll move on to the 5-axis stuff after our break. So there is a note here that's important to understand. Single axis rotation requires that subsequent tool plane matrix views, in other words planes, maintain the original matrix rotation vector. For example, if rotation is about the x-axis of the original matrix and the x-axis vector is positive, the subsequent tool plane matrix must maintain the x-axis vector in the positive direction. A reversal of the vector generates an error and incorrect coordinates. And what we're talking about I think that's all the pictures they've got. I wish they had a few more of them. But what they're talking about is when we are setting up our planes, if we're rotating about the x-axis, for example, as we rotate these vectors that form the axis system around x, we cannot allow the x to flip. And this is exactly, in answer to your question, Mike, this is exactly why you cannot use the default back and bottom planes with a top machine definition. Exactly. Because the x-axes are flipped. So when we look at top, you can see that x positive points to the right. When we look at front, you can see x positive points to the right. And when we look at back, x positive is flipped. And that is the same for bottom. Now, when we're looking at the reason they set this up is because way back when they first set up Mastercam, they set it up to handle programming a horizontal machine using front, right, back, and left as B0, B90, B180, B270. And people could be lazy and they could program front, right, back, and left, and they would get G54, G55, G56, and G57 automagically because every time the plane changed, Mastercam would see that it was a new plane and automatically increment the work offset. But yeah, that's exactly why that happens. Yeah, tool plane rotation. The 4-axis processing technique used with most Mastercam posts relies on the tool plane views being correct for Mastercam. This means that the Mastercam user must make sure that the tool plane view is set correctly for the rotation axis used when creating toolpaths. The following message, displayed by Mastercam during posting, almost always indicates that the tool planes were set incorrectly. Only single axis rotation is allowed. Angles may be incorrect. This message is not caused by a posting error. Correct the tool planes for the tool paths, then regenerate and repost the operation. Yeah, so from the base matrix, you must select a single rotation axis, and that vector component, axis of rotation, must remain constant for all the tool paths. This is also what lets you program a machine from the top view and select either Y or X to rotate about, because it just looks at the subsequent tool planes to figure out the axis of rotation. Okay, well, we're coming up on our mid-class break, so let's go ahead and take that. I'm going to go ahead and shut down the record.